Hey there, everybody. Welcome back. It's good to see y'all again. Well, I hope you think it's good to see me again. Probably not. I'm a math teacher. Not everybody likes math teachers. What are we doing today? We're going back to 4.3 now that we've done the more complicated form with ax squared plus bx plus c. Now we're doing just x squared plus bx plus c. So it's kind of like ax squared plus bx plus c where a equals 1. And I'm going to use the same method I used on ax squared plus bx plus c for the first problem, just to show you that it does the same thing. It still works. So problem 1, x squared plus, let's see, what do I want to do? 6x plus 5. That pin's dead. I'm going to throw it away. So now my a times c is 5. My b is 6. So I could do, well, shit, 1 times 5 is 6. The very first thing I try. So splitting this up, x squared plus x, or 1x, plus 5x plus 5. If I do by grouping, I have x plus 1. Here I pull out a 5 and I have another x plus 1. And I get x plus 1 times x plus 5. I'm going to do another one with this method, just so you will see the pattern all together. I'll show it on a couple problems at once, how it's working. So a times c is 24. B is negative 11. To get a negative outcome but have a positive multiplication, they both need to be negative. So negative 1 and negative 24 is negative 25. Negative 2 and negative 12 is negative 14. Negative 3 and negative 8 is negative 11. So y squared minus 3y minus 8y plus 24. I'm going to do by grouping again. Y times y minus 3. I need this to be a negative, so I need to pull out a negative here. And this should be y minus 3 again. To get that, I'm going to need to factor out an 8. I've got y minus 3. I pull out my y minus 3. And I have y minus 8 left over. All right. 2 problems done quickly with the ax squared plus bx plus c method. Let's look at the results. I had a 1 and 5 here. I have a positive 1 and a positive 5 here. I had a negative 3 and a negative 8 here. I had a negative 3 and a negative 8 here. So if you still do the table method until you can do this quickly, do the table method. It's systematic. But we don't need to factor by grouping anymore. I'm not going to say anymore. I'm going to say when a equals 1. So that we have x squared plus bx plus c. You just do drop them in. Find the 2 factors. Drop them in here. Just like we have up here. Negative 3, negative 8, I could just drop them in with the y. Here, this is where you start getting it's a little more reasonable to do trial guessing or factoring by trial. But again, if you skip it, you may not find it if it's a big number. it may be hard to find, and this gives you a systematic approach of finding it. So I'm going to do another one. This actual one doesn't start as an ax squared or a equals 1, but you're going to see that we can simplify it. If I factor out a 2, this is x squared plus 28x plus 144. Go ahead and try to find the 2 factors. Pause the video and give it a try. All right, we're looking for 144. And it's got to add to 28. They're both positive, so they both got to be positive. This adds to 145. If I do 2 and 72, this is 74. 3 goes into it 48 times. That's 51. 4 goes in. 4 doesn't go into it. Should. Yeah, it does. It goes in 36 times. That's 40. 5 doesn't. Does 6 go in? 24. We're getting close. We're either going to find it or it's going to be prime. 144 divided by 7. Nope. 144 divided by 8. Yes. Uh-oh. 8 and 18 is 26. We skipped 28. So this part is prime, but the answer to the problem isn't prime. The factor, the actual answer is just the 2 factored out. That's the factored form. Prime or DNF, if you like to write DNF. So the actual answer is this, because even though this doesn't factor, the original equation did. All right. Now let's do a complicated one. I don't know if the homework's going to have something like this, but it's worth seeing because it's a little more complicated. I'm going to have x squared y cubed minus 4xy squared minus 21y. Now the x cubed, let's just say x squared, not x cubed. The x squared doesn't have a number in front of it, so there's no number in the greatest common factor. They all look like they have a y, so I can factor out a y. And I have x squared y squared minus 4xy minus 21. And this might look a little confusing, but if you see this thing where we got 2 letters and there's 2 here as well, if I'm going to do like a little substitution thing here. I'm going to say w equals xy. So if I square w, I have xy squared, which is x squared y squared. Which means I can temporarily rewrite this as this is w squared, which is that. xy is w minus 21. Now, if I do the factors here, negative 21 adds to negative 4. 1 and negative 21 is negative 20. Negative 2 doesn't work, but 3 and negative 7 adds to negative 4. So I still got my y out front. I can jump straight to parentheses, w plus 3, w minus 7. And now that I've got it factored, I'm going to go and put w, replace w with what I had before. Now you can do this without doing the little w substitution thing, but I think it helps. I think it helps. See what other kind of problems he's got in 4.3. Oh, yeah, let's do this one. 53. 53 is ugly. Look at how bad that is. Oh my God. What are you doing, Mr. Blakely? You trying to torture these students? 5x to the fourth plus 50x cubed y plus 105x squared y squared. All right, we're going to start off looking for a common factor. And I can tell right away, these are all divisible by 5. So 5 is going to be part of it. In fact, it's not bigger than 5 because that's 5 and nothing else would divide into it. So 50 divided by 5 is going to give me a 10 on the middle one. And 105 divided by 5 is going to give me a 21 on the last one. Now what else comes out? It looks like the lowest exponent on x is x squared. And these have y's and this one doesn't. That's the final form. I have an x squared here. I have a 10 xy here. And I have a 21 y squared here. That was a little complicated. Maybe I'll do this in the table over here so y'all can see the table version. So my GCF is here and here. And I'm left with an x squared, a 10xy, and a 21y squared. Okay, so we got 2 letters now. Notice that this one is squared and this one is squared. It's looking like there might be some way that if I put x and y here and x and y here with maybe some coefficients, doing these 2 will give me the x squared. Doing these 2 will give me a y squared. And doing the other ones, the outside and the inside, will give me an xy's. So that's what we're going to aim for. For now, pretend there's no y squared. Pretend there's no y. Just add it in as the last term. Add in on the last term. So I'm going to look at this as 5x squared times x squared plus 10x plus 21. Now, if I factor this one, it needs to multiply to 21 and add to 10. That's 22. 3 and 7 gives us 10. This splits up into x plus 3 and x plus 7. And now I said pretend there's no y, but I know there needs to be a y here to get a y squared to get my xy's. I'm going to add it here on the end with the 3 and the 7. I can multiply this back out just to confirm. X times x is x squared. X times 7y is 7xy. 3y times x is plus 3xy. And 3y times 7y is 21y squared. Combining the like terms in the middle. I see that I do get what I had up here. Look at that. So it might be easier to look at with no y, just remembering to put the y back in. Otherwise, you kind of got to do trial by guessing, just so you can see it, okay? That'll be it for 4.3. We're halfway done with chapter 4. Peace.